Okay, hi everyone, it's great to have you here today. I'm Abby Hurd, I'm in the manufacturing team at Knowledge Transfer Network, where I lead on helping innovators with physical products get their idea from something in their head on paper or prototype to scaled up manufacturing. So did you know that 70% of technology startups fail? Yet 97% of hardware startups, people with physical products, don't make it. Only a small proportion of physical products ever make it to scaled production. Apart from all the usual challenges with innovation, there's extra hurdles when it comes to physical products. With hardware, there's extra dependency on the third-party relationships, a really diverse range of skills and experiences required, and significant investment is needed up front. At Knowledge Transfer Network, we work with innovators to challenge ideas and thinking about the market, the offer and the opportunity. We help develop robust propositions and we build collaborative networks to deliver results. We're looking to do more to help innovators move from an idea to a manufactured product. So in partnership with Product Design Scotland, we've set out this programme of events to achieve two main things. Firstly, we're looking to address diverse skills and experience required. So to do this, we'll provide insights from experts and experienced speakers, and there'll be opportunity to ask questions. Secondly, to help develop the need for strong relationships and connections, we want to help build a diverse UK-wide community who have an interest in navigating or helping other people to navigate this design to manufacture journey. Each week, we will be focusing on a different challenge that from experience we see recurring. This week, we're looking at managing costs, which when poorly managed, it's probably one of the top things that leads to failure. So before we get started, I'd just like to quickly introduce you to Meeting Mojo. So obviously you can't see the other delegates at the moment, but we'd encourage you to put a short profile on to Meeting Mojo, and that way you can have visibility to connect with and visibility of each other, and that you're able to connect with each other. So the Meeting Mojo, you should have been sent a link by Anita, and that will be open right through the series. If you've not got that link from Anita and you'd like to be part of that community, you'd like to connect with other people that are on this call, then let us know and we'll sort that out for you. So today we've got 3 great speakers lined up, and then we'll move on to a panel, a Q&A panel, where you'll get a chance to ask some questions and chip in. And then right at the end, we'll round up with a mention of what's coming up in the following weeks, and we'll get into a habit of letting you know if any new funding's been announced or there's other events running at that point. But for now, I'm going to hand over to my co-chair, Ali McInroy, the CEO from Technology Scotland, and Ali will introduce our speakers and he'll also run the Q&A panel for today. Thanks.
Thanks, Abby, and welcome to everyone. I'd just like to add my welcome to that of Abby's. It's great to see so many people signed up to this webinar. I appreciate that there have been, I guess, a tidal wave of webinars over the last few weeks for obvious reasons. So I appreciate that you've chosen this one today, and I also appreciate that what we're trying to do here is more aligned, I guess, to business as usual. Perhaps this is about continuing on and looking ahead beyond the situation we're in at the moment. So my name's Ali McInroy. I'm the Chief Exec at Technology Scotland, and among other things, we run the Product Design Scotland network and are your co-hosts for today's webinar. I'll be facilitating the Q&A later, so I'd like to direct you to the bottom of your Zoom screen where you'll see the Q&A button, and that is where you should enter your questions at any time throughout the presentations or after the presentations have been run. Please do use the Q&A button and not the chat button. If you use the chat button, there is a distinct possibility it will get lost somewhere in the mist. So if you could use the Q&A button, that would be great. If your questions are aimed at one of our particular panelists, it would also be good if you could identify that within that. If not, I will just put the question out more generally to the panel, or pick on someone that I think is perhaps best placed to answer. So without any further ado, I'd like to introduce to you our first speaker, who is Tristan Elliott. He's the Director of Business Development at I4 Product Design, who I'm very happy to say are a member of our Product Design Scotland network. And he's going to be talking about some of the common pitfalls around outsourcing design. So through the magic of Zoom, I'm hoping that Tristan will be able to take over from me and begin.
Yep, that I can, hopefully. Hi, everyone. Thank you very much to Ali and to Abby for the introduction, and especially to KTN for inviting me to speak today. I'm, as Ali said, a director at I4 Product Design, and I've been in and around product design and development for about 10 years now. So I'll try to squeeze my learnings in from these years into the 10-minute slot. So my apologies if the pace and the high-level nature of this presentation is a bit lacking, but I'll do my best. But happy to take questions during the Q&A and after the session as well. So I4PD, we're a design and development firm of 20 creative designers and engineers who, over the past 17 years, have helped our clients bring over 200 products to market. As designers, we are custodians of our client's vision, and one of our key jobs is to graphically visualize their ambition for the company and its products. So with a wide range of clients, these visions can be as diverse as being the retinal imaging company, the British home alarm system company, or even the automated fish vaccination company. One of the more bizarre examples of a customer's vision from a few years ago was to develop the world's first electrical stimulation device for weight loss. The company was a startup, as probably the vision can show you, but there were two founders, a neuroscientist and a neurosurgeon, who had not previously developed a product before. We became their turnkey development partner, and along with their preferred contract electronics manufacturer and our proposed injection molder, we were relied upon to give them the kind of costings that they would need for fundraising, which was quite a mixture really of government, VC, private investment, and crowdfunding. My reason for raising this particular example is because it epitomizes the competing interests that can sometimes be at play, such as ergonomic challenges, and for this product, it was a one-size-fits-all headband. The need to have a high-quality aesthetic, which points to really having a compact electronics design, and keeping both the project costs and the unit costs as low as possible, as this was a consumer electronics device and we're being in a competitive space. Whether or not you opt to use your own in-house development team, if you do have one, or those of an outsourced partner, without ensuring close integration of the design and engineering functions, you could find yourself in a situation where you have a design that is highly functional, simple enough to fabricate, but not really desirable, or even worse, possibly so. The design is really desirable, but costly or perhaps impossible to manufacture. So using an integrated and experienced design team armed with your commercial targets and market insights can deliver creative designs that you can be confident are rooted in the realms of practicality. This is what I like to call creative pragmatism. Two of the key questions that we asked this client and every other client before setting off on the road to design for manufacture, or even starting the project, were: what is the development budget?
Hi, Tristan, sorry, many apologies for the intrusion, Tristan, but I am seeing your slides in you.
Are you?
Yes.
Okay.
I think from the chat, maybe others are seeing that as well, just so we get the full splendor of your slideshow.
Okay, no problem. See if I can rejig this for you all. Believe it or not, this was actually tested. Okay, how about that now?
Good.
Perfect, sorry about that. So the two questions are, what is the development budget and target unit cost? What is the experience and capabilities of the assembled team to design for manufacture? according to aspirations and all the relevant production methods. It is not really normal to have the answers to all these questions straight away, but it is important to keep asking these questions time and time again as you make critical decisions for the design of the product. So what you can see at the top of the slide, hopefully now that's been fixed, is the list of core phases of a product will pass through from its birth to manufacture. It's really crucial to be honest with yourself as to the true cost of development and budget accordingly, or you risk what I call zombifying your project. This is where you've spent all your funds on reaching the engineering phase, but your initial investment can't cover the cost of producing production tools, let alone your first minimum production quantity order. So prepare your cash flow projections accordingly and push for favorable payment terms from your partners, such as small upfront payments for each phase of design work, with the remainder of your payments payable on deliverables. And that's when you've absolutely 100% happy with the quality and you can sign off on it. Project costs do ramp up towards manufacture. As you begin to produce higher quality, higher fidelity prototypes, start to pay for third-party test house fees, and more often than not, have to fork out 50% deposits for any tooling. It is important to also account for import duties when procuring prototypes or tools from overseas vendors, as this can be an unexpected addition of 20% to your costs. If you are working with a design partner or manufacturer, make sure you're getting a quote that covers you right from where you are on your journey through to gold standard production samples. Ensuring they have included physical prototyping as an activity within the concept and detailed engineering phases, and make sure that you have as much contingency, or you know how much at least they have included, into both the budget and timeline to account for iterations and learnings from these prototypes. When briefing the consultancy, make sure you are clear on what you expect for them. For example, who is to produce the assembly drawings? Who is to undertake design refinements during production sampling? And who is to produce test jigs that may be required? Unless otherwise agreed, it is generally not something that manufacturers throw in for free, and is a cost that you will have to bear, or the design consultants should quote for if you're not doing it yourself. One cost that you shouldn't have to factor in is large-scale design changes after an engineering phase, which is where your design should be technically frozen. The main reason for a design change just prior to or after design freeze is due to inexperience, really, which can be compounded by the fact of not having internal reviews or not carrying out reviews with the contract manufacturer that you've selected. And this can happen as early as you actually do have some kind of design drawings or spec to show to them. It's rare to recover from these kinds of changes, as usually it means you incur the cost of redoing that part or all of the engineering work entirely, and potentially scrapping an inexpensive production tool. One of the most important pieces of information a designer can be fed is the target cost for a product. Manufactured, assembled, boxed, and shipped. It's important to include all those factors. A target cost allows for practical concepts to be generated around part count, materials, processes, off-the-shelf custom routes. When I say part count, that could be including a decorative trim or trying to consolidate several parts into one, possibly either contributing to strength requirements or conversely. So your target unit cost can be worked out roughly by taking what you intend to be the retail price and deducting distribution costs and what your desired margin is that accounts for your own costs and your profit aspirations. It's not uncommon to use several different fabrication processes to produce the parts for one product. This means that to achieve your marketing and technical requirements, you should consider various tooling options and budgets associated with these processes and plan accordingly. It will mean that your designers should be comfortable with both plastics and metal, and you will likely have a large number of manufacturers in your supply chain, which either you or your consultants will need to manage. At I4PD, our team have created a platform for estimating the tooling and unit costs, so we can give our customers an early indication of tooling and unit cost for their NRE budget. Throughout the project, we refine this estimate as the design evolves and as we have more detailed discussions with contract manufacturers. It may be that there is no budget available for tooling and that all funds must be diverted into the design and engineering of either the first earliest testable product or the earliest sellable product. This could be a combination, for example, of sheet metal, which needs very little tooling investment, and additive or subtractive manufacturing, which needs none at all. The trade-off of this is the unit cost will be far higher as a result of selecting these slower, lower volume manufacturing processes. However, it could be a viable option as a means to an end where you need to prove a concept either works or is capable of generating revenue for your investors or backers before progressing the design to a design that can actually earn you a decent margin. High volume process, and two of these are shown here where I'm talking about low thousands to millions of units, like injection molding and die casting, will attract tooling costs that can ultimately result in parts that are a fraction of the cost. The same does apply to electronics, where you might have the choice of using an off-the-shelf Bluetooth low energy module or integrating your own chip solution. You'll need to do a cost calculation to decide at what volumes it will make sense to design, test, and qualify your own versus the additional cost of buying a pre-certified module. A recent study we undertook found that the tipping point was around the 200,000 unit mark. So these kind of calculations should be done roughly, and then as you get better marketing projections, should do them again. So my two top tips for managing your budgets and making sure you avoid the common pitfalls are budget comprehensively for everything, which includes your designing, your prototyping, testing, tooling, and manufacturing setup costs, and include contingency. This can be around about 25% as just a rule of thumb. Build internally or partner with a team that has experience with the applicable manufacturing processes to ensure the project runs efficiently and you avoid expensive and potentially catastrophic issues, just as you thought you were nearing manufacture. So thank you very much. Happy to take questions in the Q&A, and I'll pass back over to Ali, and apologies for showing all my secret notes.
No problem, Tristan. There was nothing untoward there. So, many thanks for that. So we will run the Q&A after we've heard from all three of our panelists. I've seen there has been a question come in already. That's good. Please do keep filtering them in at any time through the Q&A box at the bottom. In the meantime, as Tristan passes over the technical reins to David, I'll introduce David. David Cullimore, he's the Head of Innovation at ProDrive Ventures, and he is going to elaborate a bit on scope definition and good prototyping strategies. So hopefully David will be beavering away in the background, getting his screen ready for us. How are you managing, David? Are we getting there?
Sorry about that. I dropped out for some reason.
No problem.
Right, can everybody see my slides and can everyone hear me? Good, right. I'll begin. Let me give you a brief introduction to ProDrive before I start. Some of you may or may not know who ProDrive are. ProDrive started as a motorsport entity, and it's still, a very, strong part of what we do today. But today we are so much more than motorsport alone. We have a advanced engineering division which works on many different items beyond motorsport products. We have advanced composite manufacturing business. We have also a branding and merchandising business. But the division that certainly I look after is a ProDrive Ventures investment arm. So we have an investment division within ProDrive which specifically invests in early stage businesses and typically that are developing hardware projects. So we have an investment model which invests our engineering services into these companies, typically in exchange for equity. And through this experience, we have some, insights and tips that we can give, which will hopefully be helpful to you. But we have a sweat equity deliverables-based model. So what we invest is known, and you'll have a specific outcome at the end of this investment. And also, just a point of note, we also run a startup competition called the Rapid Challenge, which is, again, specifically aimed at hardware startups, and we'll be running that this year in 2020. But to talk a little bit about managing costs, certainly from our perspective, and Abby and Tristan have touched on a few points, and there are some general principles that we can tell you and speak about, but this will fundamentally depend on the type of project that you're doing. There are several individual nuances that you'll have to factor in, and there's no right approach. Each will depend on the individual circumstance in the project that you're doing, and of course this will depend on the resources that are available to you. But along with that, I mean, there's a few fundamental things that you must understand, and one of the large points is that you're likely to have to make a significant commitment at some point. This might be in the case of, manufacturing an MOQ, or it might be a tooling fee. So you appreciate the fact that you have to build up your development process to a point where you have to likely sink a lot of costs into one point. And also appreciate the development costs that, you have to have a base amount of knowledge to be able to make some informed decisions, because fundamentally the costs will be based on the decisions and quite often the timing of those decisions as well. One of the big things that we see that can affect costs is the pace of commercial and technical development. So quite often when you're in the early stage of developing a business, you're trying to understand your customers, how you're going to develop a product and how you're going to deliver some of this value to these customers. And one of the most catastrophic impacts can be manufacturing the wrong product. So either you have misunderstood how your customer's going to value your product, or it might be a case of it can't be made for the right price point. There are many different pitfalls, but quite often this is caused by a discrepancy between commercial and technical development. Either those, too strong a commercial development, or it might be the technical development is too far along the line. It might be, we've heard cases where people have been ready to press go on tooling before they have done any types of, user testing. So one of your key skills will be your ability to test your assumptions. And I'll cover some of those in the prototyping section, but prototyping is not only for technical, it is very much also for testing some of your commercial assumptions. And this testing of assumptions is key to de-risking before manufacturing. As I say, you're likely going to have to make a commitment, so therefore do as much as you can to de-risk that point in time. The importance of defining a scope. You might be known as a specification, but fundamentally what this does is capture the attributes and requirements of your product. And of course, this will be based upon your understanding of the market, the target customers, how your product will deliver the value, everything that you've done up until that point. And there's a couple of kind of core reasons why you should do this exercise. It creates a level of focus to your development process. I mean, this is key. The development phase is a costly element, and you want to be as efficient as possible. And one of the ways to do that is to tightly define your scope, because variance in your scope can ultimately be very costly in the long run. And secondly, it reduces the likelihood of unexpected surprises, because you're going through the whole process, the motions of thinking about all aspects of your product to reach a point where you can produce something that your customers will value. Just to give you a brief example of what I mean. So this is the Hummingbird bicycle, which is a company that we invested in. We also helped manufacture the frame and several other components. And what they were after was creating the world's lightest folding bike. Now, there was a couple of reasons for doing this. This was to solve a user pain point. Existing folding bikes are very heavy, they're difficult to move around, but also it was a unique value generator. So for them, it was something that they could market, something they could shout about. So their focus was fundamentally about weight. Their product was designed for adults to be used for commuting, for leisure purposes. So this kind of gave them some of the parameters that they were looking for. But this focus was able to create a scope of a defined scope that they were able to take onto the different phases. So this then defined the materials that they had to use. So in this case, the frame is manufactured from carbon fiber, and then therefore that dictates a manufacturing process and all the knock-on supply chain effects and assembly, etc. So without having this level of scope, particularly a startup in this case, they wouldn't have any other opportunities without having this kind of tight laser focus on what they were targeting. Understand the ramifications of your actions. This is particularly important when using external resource, because it's likely that any change, particularly post engaging engineering or even manufacturing, will come at a cost. And understand that if you're going to make a change, that this will come at a cost, and also likely to delay things. So minimize the amount of changes that you can make. Of course, I'm not saying don't make any changes, but understand that it will come at a cost. Equally, be mindful that indecision can also be costly. This might be the fact that you're delaying to do some more market research, and you may have a manufacturing slot lined up, which you may lose. But also be mindful of kind of hidden costs. There's also an opportunity cost that you have to factor in. There may be a gap in the market or a commercial window that you're trying to chase, and any delay may lose that opportunity. So one of the top things is to make sure you understand the processes that go into making your product. And without that understanding, you won't be able to make these sound decisions that you need to make. Prototyping strategies. Now, as I said earlier, this is really important to de-risk some of the commercial but also technical elements of the development phase. Understand what you're trying to prototype, what you're looking to test, because you're not prototyping for the sake of prototyping. You're prototyping to test some of these assumptions and to de-risk the whole process. So in order to establish an efficient prototyping strategy, make sure you look out for what you're trying to test. In addition, question what has to be physically prototyped. There's often a bias for people who live in the world of physical products to immediately jump to making physical prototypes. There might be a lot of things that you can do to prototype things virtually. For example, you might be able to gain some customer feedback by showing some renders. Things like that, you'll be able to do, increase your iterations without significantly increasing costs. So you can gain a lot of things by doing things virtually. Again, look for the tools that you can use to reduce cost and increase certainty. There are tools, for example, like VR that can be used very effectively. The truck concept on the left is a virtual representation, and you can try 20 different layouts of the screens and the button systems in scale with different users, all virtually, in a time frame and a cost bracket that would be unattainable in any other way. So look for other tools that you can use to prototype things at a significant reduced cost and increase of speed. But also just be mindful that you might not be able to prototype every aspect of your product. For example, you might not be able to test the exact materials. If it's, say, an injection molded product, you might not be able to test realistic materials or full types of function. You may have to do several different prototypes, and only the final product will have all of the features in one. Just be mindful that at some point you will have to make a commitment which you might not be able to test all of it. So just to kind of cap off, these are the kind of 4 different aspects of managing costs. Learn and appreciate the processes involved. Make sure your technical and commercial development keep pace with each other. Define a scope and make sure it is focused and built upon the research that you've done, and test your assumptions via prototyping as much as possible to help de-risk before manufacture.
Okay, thank you very much, David. Okay, we're going to move on to our third and final speaker now, that'll be Hannah Leslie from the Product Realisation team at the AFRC. The AFRC are also a sponsor of Product Design Scotland, so this gives me an opportunity to publicly thank them once again for that support. But now, hopefully, I can see the screen is up and running, so hopefully we'll be able to hear from Hannah in just a second. Over to you, Hannah.
Thanks very much, Ali. That's just confirm that everyone can hear me and see my screens all right there. But yeah, as Ali says, I'm Hannah Leslie. I'm a Knowledge Exchange Associate at the Advanced Forming Research Centre, or the National Manufacturing Institute of Scotland, which is one of 7 high-value manufacturing catapult centres from around the UK. So basically, our remit is to de-risk and accelerate the introduction of new technologies, materials, processes, and particularly in our team, I work in the product realisation team, where we're primarily there to support companies in their product development journeys and to help with the verification and validation aspects that go along with that. So today I'll be kind of focusing on the importance of thinking about the cost and the feasibility of manufacturing your product, and the importance of thinking about it as early on in the product development journey as possible. So I'll be highlighting a few kind of key design considerations that you should really be incorporating to try and keep these costs as reasonable as possible. There is a bit of overlap with Tristan and David's presentations, but it's all good to give you a holistic view of everything that goes on in this journey. So this model here, basically new product development can be seen through this model. It's called the 3 lenses of innovation, but it basically aims to demonstrate that to have a successful commercial product, people have to want it, so it's desirable. You can actually do it, it's feasible, and it makes financial sense to do so. It's viable. So basically, if you can get these all aligned perfectly, you're in what's referred to as the innovation sweet spot. And you can apply this model to any area of your business, but we are specifically looking at the manufacturing of a new product. And in this case, most early stage growth companies can create a technically viable prototype, but do then struggle with engineering challenges relating to cost effectiveness, implementation, and market viability. So in other words, it's cool design, people like it, but is it actually doable? Can we do it? Maybe not. Let's have a look at that. But by understanding the connection between product design and costs, you can potentially begin to make some decisions earlier on that will eventually lead to higher margins, lower costs, and potentially more sustainable growth. So it's good to take consideration of all of these aspects. So if we split it out to look at each aspect in a little more detail, during the bulk of your design thinking work, desirability is generally at the forefront. You're concerned with creating your great idea, testing your ideas, and validating your hypotheses about your users. And as David touched on there, you're really wanting to test with these early stage prototypes and generating feedback off of that. But you should also be, towards the middle and especially towards the end of your project, you should be really bringing the focus to the feasibility and the viability so that you can have a sustainable solution. So generally, desirability focuses on, how can we make this design everything that our customers want? How can we factor these additional requirements from feedback into the product again? And how can we be more responsive to this feedback? So this is the front end human element of product design and development, where you're getting as much feedback as possible, going through concept iterations and looking at market data and other activities such as these. But as we're doing all of this activity, as I mentioned, we really should be keeping an eye on both the feasibility and the cost of this product. So, can it be manufactured? Can it be manufactured efficiently? And can it be manufactured at a cost that is viable for the business? Or do we need to have a look at the value proposition of the product? So, for example, you could introduce a product at an unrealistically high price point due to increased production costs, or you could unintentionally design a product that is too complex to manufacture at scale. At a reasonable cost, or you could ultimately eat into your margins by not fully understanding all the costs associated with your product. For example, some of the hidden costs that David just discussed. So particularly looking at feasibility, so we're looking at so when we're looking at viability, we're looking at things such as, does this product respond to market trends and drivers? Is there a large enough market for this product? What is the value of this market? How much of that market is actually accessible to you as a company? And if we know that, and we know this information and we're comfortable with that, then the follow-on questions from that will, is this target market actually going to accept our product based on the standards and codes that they conform to? So at the AFRC, for example, we work with quite a lot of heavily regulated industries such as aerospace or oil and gas or medical devices, for example. And you really need to understand the codes and standards that apply there. Otherwise, you might have a wonderful product, but it's just not going to be accepted into industry. And oftentimes this might actually dictate the method of manufacture that you need to use to some extent. So for example, at the moment, additively manufactured parts aren't yet widely qualified for use in oil and gas, especially not for critical applications. So that would be something that you would need to know early on before you started trying to make a product for application in oil and gas. So finally, once you have an idea of what manufacturing and production costs might look like, does the value proposal for this product make sense based on those target costs and volumes that you want to achieve? So it might be that you need to revisit your positioning strategy for endpoint pricing, or you might need to look at other areas in the value stream where costs can be salvaged. So just some thoughts to leave with any innovators here today, kind of on this journey. Regarding viability, do you know your market inside out, and are you comfortable with that? Have you nailed down your target costs and volumes? Both will ultimately have a direct influence over the method of manufacture and the cost of production. And finally, just don't be scared of manufacturing costs outright. It might be that a more expensive manufacturing option makes more sense in terms of quality, supply chain, risk, reliability, waste reduction, material usage, and a whole host of other factors. So it's really important to look at your entire value chain and value proposition holistically, and work with your designers and manufacturers early on to help you develop that, and look at areas that you can have a consideration of. So moving on to feasibility. This involves the actual manufacturing of the product itself. So can it be manufactured? Can it be manufactured efficiently? So these might seem like obvious questions, but we've definitely worked with some amazing innovators at the AFRC in the past who have a great CAD model. It's been optimized for purpose. They've done simulation testing with it, and they've got 3D printed models, and it's all really looking very positive. But now that they've come to us for support for manufacturing feasibility, it turns out the model's not, actually currently manufacturable at a realistic cost by any process. So we do need to go back then and address the design and look at alternative routes. So if you have a particular method of manufacture in mind, for example, in a sector that dictates the method of manufacture, so you know that you need to go with this one type, has this been considered at every stage in the design? And will this design be cost effective for this particular method of manufacture? These are just a couple of things to consider. And finally, and this is quite an important one, regardless of what method of manufacture you're going for any stage in your product development journey, is there a reliable supply chain in place for the manufacturing method that you're going forward with your product? So you don't want to find yourself in a position where you're having to single source from a supplier because they're the only one offering it, or having to source from fragmented supply chains that are entirely based overseas. Because, as we've seen in the current situation, this does leave you in a significant position of risk, and it's all about de-risking at every stage along the way. So on that note, just a couple of thoughts for the innovators again, regarding the feasibility aspect. Work with designers and manufacturers as early as you can in the process, preferably while it's just still a thought in your head or a sketch or a simple CAD model. They will be able to guide you and identify areas that might become problems later on, and will be able to help you optimize your design for a method of manufacture to make it as cost effective as possible. This was touched on earlier by Tristan, I think, but it's to establish where your design freezes should be early on in the development timeline. It is normal to go through a couple of iterations of a product based on customer feedback early on. But by the time you're looking to, optimize for a particular method of manufacture, or you're creating representative prototypes, or, you're looking to get your products tested with external testing providers, any iterations can become really quite costly and time consuming. So finally, just in terms of the supply chain, don't be afraid to shop around, look at potential supply chain partners, look at different methods of manufacture, see how many firms are offering them, make inquiries, make connections, and really do a lot of networking there. It does help de-risk the process when you come to putting your product into production. So finally, these are just a couple of points that highlight areas where cost can be influenced during the design stage. Most of them are just good design practice. So I'm sure a lot of you here will be familiar with them. But I think it's worth highlighting, especially just for those who are very early on in the design to manufacture journey, or just don't have that much experience with it. But as I've discussed, design decisions can have a real domino effect on the rest of the value chain. So one of the first things to consider is minimizing the part count of your product as much as possible. So generally, the fewer components, the less quality issues in the supply chain, less parts to maintain, and faster assembly. So try and look for ways that you can combine functions in your design and reduce the final number of parts for assembly. In line with this, where possible, using standard off-the-shelf parts as opposed to bespoke parts can save quite a lot of money down the line. It could be anything such as fasteners, caps, bungs, fittings, connectors, inserts, etc. These parts will have already been invested in terms of capital equipment, process development, testing, validation, and so on. So you don't have to do that part yourself. So it can result in some quite significant cost savings for you. I suppose it is worth highlighting that there is a risk with that in that you're relying on an external partner for the production of some of the parts of your product. So you'd have to just be aware that might leave you open to risk if it's not accounted for. But overall, it's quite a beneficial way to leverage costs for your design. I touched on this earlier, and so did a couple of the other presentations, but design iterations can become more and more costly the further down the development path you go. I think some people can think it's easy as going in and tweaking a CAD model, but any change you make here will have to be reflected all the way along the product development process. For example, the analysis and simulation used in verification prototype, the analysis and simulation used in verification, prototypes used in validation, tooling, and so on. So it is sensible to have a few earlier stage low fidelity concept models to demonstrate form and fit and to get feedback on. But by the time you're creating representative pre-production prototypes, for validation testing or even beyond that, you don't want to be, for example, investing in tooling only to then go back and make a design change that renders it useless. The reduction of weight wherever possible. So excess material means extra cost. So this is definitely an avenue to explore during the design process. So for example, using ribs and gussets to reinforce a product where strength is required instead of just making, a big muckle product. It'll save on material consumption and might help with getting uniformity in wall thicknesses. However, this does come with a caveat that it's best doing this up front by minimizing raw material size, giving you the best buy to use ratio instead of just, starting with a big block and machining it all the way later, because in that case, you're just paying for the material twice and once to remove it. So these next two slightly contradict our remit at the AFRC, which is to promote and support the development of novel methods of manufacture in the UK, but it does come with a caveat that if you shouldn't be designing for a particularly niche manufacturing method such as rotary forging or rotary friction welding unless the value added is justified. So for example, there's a reduction in material usage and lead time, or if it removes secondary or tertiary processing or allows reduction in part count, or indeed if you're planning on manufacturing in-house. And finally, on that note, if you're not manufacturing in-house, just make sure you really know what your supply chain looks like and assess and mitigate any risks that you can before going too far along the chain and opening yourself up to risks. So that's everything from me. Please do feel free to get in touch, and I'll let us get on with the Q&A. Thank you.
Brilliant. Thanks, Hannah. And thanks to David and Tristan as well for really a very thorough overview of some of the issues that some may face when, I guess, considering costs on this pipeline and on this journey. I have seen a number of questions coming in, and what I've also noticed is that when I'm sharing my screen, I can't see them. So that's a slight issue. Hang on a second, there must be some way around this. I found them. Panic not, we have them back. Okay, that's good. So yes, so there's been a steady stream of questions coming in. Thank you all for those who have put those in already. We have about 10 or 15 minutes to get through them. We may not get through all of them because there is quite a few. If that is the case, don't worry, we'll be sure to make sure that your question is put in front of our panelists, and we will get an answer to you one way or another. But what we'll do now is just go through these as they come in. I'll probably jump around a little bit so we're not firing all the first questions at Tristan, because they are the first ones coming through. Having said that, we'll start with you, Tristan, since question number 1 is directed towards you. Tristan, do you have your own in-house cost modelling approach for tooling and component costing?
Yes, we do. So I mentioned that we have one. That's for injection molding. So it's not for die casting, although the principle does apply. So basically, it's an Excel macro sheet where if we can assume a part number and a part weight, and we understand what the material is, for example, ABS, we can calculate what the part cost is going to be. On the tooling side, it's a little bit more complex. We have to make some assumptions about, again, based on the complexity of a part, will there be sliders or is it a straight open and shut? And that informs, and also particularly when it comes to, is it a hardened steel tool or is it an aluminium tool? Then at the end, we get a rough approximation for what the steel or aluminium tool will cost. But again, that is a ballpark and needs to be firmed up once you actually have a design file that can be shared with a manufacturer. They won't take sketches. They actually need to have 3D CAD to be able to assess that, or at least 2D drawings. But they will not put their any estimate to it unless they have that kind of a design file. So we try and give this early indication, this early ballpark when you're just having discussions with someone, just to guide their funding aspirations, really. Hopefully that answers your question, Rory.
Was from Rory, yeah. And actually I'm going to give Rory a 2-for-1 here, because he's going to get the next question as well, just as it happens as I go through. So this one is, it's aimed at David, but I suspect perhaps there'll be input from other panelists on this particular one. David, have you seen scenarios where products have been where products have been rushed to market due to commercial drivers, the example being funding, and have consequently failed?
The short answer is yes. Simply, I mean, there have been a number of projects, seen all manner of projects in different stages, whether it's crowd-funded or VC funded or whatever the types of projects, it's failed because it's rushed. But that doesn't necessarily highlight the root cause of the failure. So it still might be the case that the product doesn't deliver customer value, or they've underestimated costs, or there are a number of reasons why it still could fail. And of course, the post-failure point of investigation is key, because that's the point at which you can learn from mistakes and hopefully have another stab at it. But ideally, before that point, you want to do some tests and reduce that risk.
Okay, Tristan, Hannah, have you got anything to add to that particular question?
Timelines are always a challenge, and the expectations of them. So yeah, timelines, speed to market seems to be one of the biggest drivers of any plan that we are asked to put out there. And we do try and push back as much as possible, because like David, we have seen failures based on not having enough time around prototyping, not needing enough time for actually procurement of a prototype. So giving yourself enough breathing space can definitely mitigate the risk of a failure.
Yeah, I think I would just agree with that, in that I think in the previous navigating to design to manufacture journey, it was touched upon that it's really important to just be realistic about how long a product development project will take. And although there might be good reasons behind needing to expedite that process, ultimately sometimes it's not possible, or sometimes there's just too much risk for yourself associated with it, even if in this example there's funding behind it or whatever.
Yeah, the old ×2 timeline forecasting model seems to get brought up frequently at that particular event. So coming back to you, Hannah, for a more specific question before we move on to a more general one. It's come through. Could you elaborate on additive manufacturing not being a qualified method of manufacture for oil and gas? Quite a specific question.
Sure. At the moment, I don't know too much of the specifics. If you want to talk about it a bit more afterwards, I'm sure I can put you in touch with some of our engineers who'd be able to explain it much better than I can. But basically, because it's still a developing manufacturing process, it's about developing a guideline towards certifying parts in oil and gas at the moment, which isn't widely accepted at the moment. So there is work being done on that, but it's not widely qualified for use in high critical applications. So feel free to get in touch though, and I'll get you a bit more information on that.
Definitely, thanks, Hannah. And I think this is probably another more general question. If a project does require further redesigning, so that was mentioned by I think all of you at various points, but has proceeded past the engineering phase, what is the best way from your experience in addressing that problem? to whoever wants to answer first, or I'll pick on someone. Okay, I'm going to pick on Tristan because you're at the top of my screen.
Okay. So how best to progress? Well, it depends on the severity. Is it the entire product, the whole system that needs to be redesigned, re-engineered? In that case, you could be looking at a few months to actually undertake that. And if that's with a consultancy rather than just someone who's on your salary, then that can be tens of thousands of pounds. And if you've already undertaken tooling, then that can be further tens of thousands of pounds. So if you can overcome that and the actual timeline, that's great. But if it is just one single part that hasn't been designed for manufacture, you can still use the CAD, you have the native file, you can modify it to have draft angles, move undercuts. That's maybe a week's effort. So it really depends on the complexity of the product, how deep the issue goes. But we've seen projects that have been saved and others that unfortunately couldn't be because the funds just weren't there or the time wasn't there to rectify it. So it's a bit of an iffy answer, but hopefully there's some optimism there as well for you.
Yeah, I think just in terms of that as well, it also just depends how far along the engineering journey you've gone, because if you've already invested tens of thousands of pounds in tooling, for example, that's obviously a massive financial hit. If maybe we've taken it up to the point where we're doing simulation or, virtual verification of a part, then that's easier obviously to go back and tweak. So it kind of is on a sliding scale. And I would say, the more physical your product becomes, if you're presenting representative prototypes, that's going to be harder to overcome. But as Tristan says, it's not impossible if you can manage the funding aspect of that and you can go back and readdress the design changes that you need to make.
One point I would like to make is if you are using an external party to do your design work, make sure you, in the agreement or in discussions, are guaranteed access to the native CAD, whether that's SolidWorks, Pro-E. We have seen some companies get locked in with consultancies or manufacturers where they've not been given that information. They only get the output file, which you can use somewhat, but you can't actually modify the direct geometries of it. So make sure you get access from the start to that native CAD, because then you can do the changes that Hannah and I just mentioned.
Just like to add one kind of final point on this question. I mean, there might be areas of your product that you can't finalize yet, but you may be able to start on other aspects of your project first. So there might be areas that that you're not going to have certainty for, that you can delay later and start on other aspects. So it really depends on the complexity of the project, the type of project, if you can isolate elements like that. But any changes are not great. Ideally, you do want to avoid them as much as possible.
Okay, thanks guys. We'll move on to the next question in interest of time. So this question, I guess, is fundamentally around state of readiness, I suppose. So how much does it benefit the process coming ready with, for example, a TRL5 prototype and a bill of materials? So I guess more broadly to that, what is the, and this was a question I remember was kind of asked at the physical event we held in Glasgow. What do you guys look for as a kind of a bare minimum or a preferred entry point to this journey for you guys to engage?
Should I go?
Yeah, absolutely.
That's better than we usually get to have something that's at TRL 5. So you've actually got a physical demonstrator. You've undergone some testing of that. You understand what features you probably want to have, and you've tested some of them. So that really helps us to quantify the challenge to go from there into production. So there's a lot of unknowns that have already been ticked off. So it gives you better sight and a better estimate, basically, of the work to be done. So it's ideal. We do work earlier than that, from basically just a brief from the set of requirements, or even help make the requirements. But then it's really how good is your crystal ball and how similar is this project to other ones that you've undertaken and the technical challenge at hand. So it's ideal if you're at that stage, really.
Yeah, I think on that, yeah, we're similar in that, we'll take projects on even if they're sketches, as long as you've got basic things in place, such as, what are your target costs, what's your defined scope, what's your strategy, funding strategy and prototyping strategy, a couple of the points that have been mentioned today. But it is beneficial to already have a laid out model and a laid out design. However, depending, as I say, we often sometimes get people in that have beautiful CAD models and they're great and they look great, but they're not necessarily great for manufacture. And don't get too attached to it, is what I would say, because there might be optimization routes that you hadn't considered with your design going forward.
I mean, from a ProDrive perspective, we typically we accelerate the TRL process, so we can often start below that at TRL level 3 and bring it up to there. So from a kind of ProDrive engineering hat perspective, that's it's fine, it's not a problem, it being lower down the TRL perspective. From a kind of investor perspective, you've got to ask whether or not, again, you might be advanced on the TRL stage, but does it deliver the value, and is the commercial backing there behind the product? So, if you're an innovator looking to bring a product to market, it's all well and good having a well-advanced technical product, but does it deliver on all the other aspects that you need to make this a commercial success? So it really depends. But and again, it links back to how much of it you can develop yourself. So if you've already reached TRL 5, can you go a bit further? Clearly identifying the areas that you can't do and the areas that you need help on. That's the key to being efficient is doing what you can and then applying the funds where you cannot continue any further.
Okay, I'm going to do just two very kind of quick final questions. One is a very specific one. Sorry, Tristan, to come back to you, but it's the first question asked, so I think they deserve their answer. Would design companies typically have a preferred manufacturing partner?
We have a list. So that list is produced through people speculatively getting in touch with us to say, you're a design consultancy, you must have a need for widget XYZ and contract services XYZ. We also go to trade shows when we have a specific need, a specific material or process that we've not used before. But we do not have any commercial arrangements with them. We remain completely independent and agnostic as to who actually gets the work. We typically go through the same process that any innovator or manufacturer should go, which is an RFQ process where you send them design files under confidentiality agreement, get them to quote for it as they see it, because that way you stay competitive on timelines, lead times, and also on the committed cost of production. So short answer, yes, we do, but it's a verified list and we always keep them on their toes, as Hannah was saying.
Okay. And just as a final question before I pass you back to Abby, it's a kind of more general one again. Do the panel find clients are adequately prepared strategically and commercially when they first engage on the design for manufacture journey, or could there be more thinking and testing done up front? And I guess it's an important kind of extension of that. To an extent, does it matter, or are you quite happy to engage in those conversations at an early stage, perhaps regardless of where that development is to that point? Who's going to start me off?
I'll go. I mean, I think was it Hannah that mentioned that starting early is great, and I agree. I think it's certainly a good idea to start having these conversations early with manufacturers or suppliers or whoever it may be. But my comment to that would be that it is still not a substitute to doing your own research and homework behind the processes and practices involved, because without having that base level of understanding, you can't have that conversation. You can't make then the rational decisions that you need to make that have a massive impact on your business. So the whole strategy will be affected by the conversations that you have. So, I mean, we've had all sorts of conversations where, they lack commercial acumen, or they're lacking in the technical aspect. And it all varies. I mean, all I can say is it's helpful to do as much homework as possible, and certainly people like us will help you along the journey, and absolutely come and talk to us if you've got a project that you want to discuss. But for your own sake, to be able to make the decisions that you need to make, do as much homework as possible is what I would recommend.
Yeah, I would agree with that. Just do your homework. Obviously, we're more than happy to work with you at any stage. And if you need technical input, then that's absolutely fine. We'll help you out with that. But as we've all mentioned, I think it's knowing that commercial viability aspect of, well, how many do you need to make, or do you think you can make, and how much is it going to cost? And you know, nailing down those target costs and nailing down your target market. And particularly for us, when we look into our kind of high integrity or critical applications, it's really understanding what the application is for your product and what barriers there are in terms of, you know, standards or codes or particular manufacturing issues that you need to be aware of before we go too far down a development line, and then, you know, it turns out that there's something really impeding development because of something that's come up that you weren't aware of before. So yeah, just agreeing with David on that one.
Okay, thank you guys. I think we are now officially sort of out of time. So I guess big thanks to our panelists, and also to you guys back in your homes or wherever you are, for submitting your questions. I hope that today's session and Q&A session has been of value to you. I think the message that I was getting, which was quite similar to the physical meeting that we had in Glasgow last month, is that for a lot of innovators, this journey can be quite a daunting one, particularly if they haven't done it before. A lot of things to consider, but the message seems to be, like, absolutely do your homework, do the basics, but there are lots of organisations out there and companies who can also help you along that way, and to engage as early as you possibly can in that process to avoid some of the pitfalls, some of the potentially very costly pitfalls further down that journey. Okay, so thank you all again. I'm going to pass you back now to Abby, and she's going to wrap up today's session.
Thanks for that, Ali. Cheers. Thanks, panelists, and thanks everybody for all your questions. Hopefully you found that session interesting, and if so, we've got a whole series of these lunchtime webinars lined up. You might have seen that already. So next week we're doing one on design processes. Oh no, so business propositions next week. Then we've got one on scaling manufacturing and one on design processes. And I know these guys are hard to beat, but we've got great speakers lined up for following weeks as well. Just encourage you as well to sign up to Meeting Mojo if you've not done it already. So from this afternoon, you'll be able to arrange meetings with the other attendees that were on this call. You'll get visibility of who else was on the call and start to be able to connect with them. And what we'll do with the questions that weren't answered is we'll share them with the speakers, and we'll get back to you on those. We'll also have a look at the ones that have been answered already if anybody's got anything else to add to that. So I think that is us for this week. Thank you all again, and thank you to our speakers and panelists.
Thank you everyone for joining.
Thank you.
Yep, thanks very much.
Yeah, thanks everyone. Bye for now.
Bye.
Bye all.